Welcome to my talk, Why I Bet My Business on React. Before we jump into it, I want to introduce myself. My name is Jess Telford. If you're following along at home, you can find these slides and click the link at the bottom right there. I'm on Twitter as Jess Telford, GitHub as Jess Telford. You'll find me everywhere as Jess Telford. If you Google my name, I think the fourth search result is not me. It's a 17-year-old girl in the States, just in case you got confused. I've been a front-end dev for a number of years now, and I've worked at companies big and small. I've worked at Groupon recently. I was leading front-end architecture at domain.com.au, property and real estate there. I used to work at Yahoo. I've worked at a few startups around Sydney. I've worked in San Francisco as well, so I've quite a varied experience, and I'm hoping that I can bring that experience to the talk today and tell you a little bit about why I think React is worth betting on. I'm also a family man, so these are my two young boys. This was last weekend, went and got to feed the kangaroos, which was a bit of fun. You can see that Dad got to dress them by the socks. Pulled halfway up his legs, so that was a bit of fun. But these days I am working on my own company, a little startup that I called Cete. Cete is the collective noun for badges. So if you're wondering why there's a badger there, that's what it's named after. We're tackling problems that organizers have for running local meetups. So we help meetup organizers coordinate speakers, sponsorships, and their communities. I'm an organizer myself. I've been running React Sydney for the last 3 years. It's in the top 10 tech meetups in Australia. I have run other meetups in Sydney and abroad in San Francisco. I've run music festivals in the past, of all things. And coming up at the end of November, I'm running a conference called Code Heart Design. Check it out, codeheartdesign.com. We're looking for speakers as well, so if you're interested. Cete is our attempt to make organization of these events much easier. Being a developer, I'm building all this myself, and I've chosen a tech stack that I think works really well for now and into the future, and that tech stack is Node on the back end with GraphQL as the API layer and React on the front end. You might have guessed it wasn't Angular. And I want to tell you why I chose React. But before I do, I want to set up a bit of context, and we'll talk a little bit about history of front end. So back in the good old days, it was just HTML. I think HTML was in the first kind of released as a thing, the spec in the very early 90s. CSS was, check my notes, was 1996. CSS was released and JavaScript was 95. So JavaScript is 23-ish years old now. Believe it or not, but in the early days it was just HTML. Browsers really couldn't handle any kind of complex JavaScript. They couldn't handle any kind of complex CSS because both the computers and the browsers were a bit too slow to be able to handle it. There was also no consistency across browsers. We'll touch on that a little bit later, but we still feel that pain a little bit today, but nowhere near as much as it was in the very early days. So this is an example of a website from 1996. Where it is just HTML. There's a little bit of CSS in the top there. This website's still live today, which is amazing. And there is now JavaScript being added to it, and of all things, it's a tracker. So as long as you got your ad blocker on, there's no JavaScript on this page. There's a little clue in here. Can anybody guess what website this is? Space Jam. That is right, the best website on the internet. Check it out, spacejam.com. It's still live today, it's amazing. So this was 96, and then we moved on to the noughties. This is where Web 2.0 was a thing. Gmail came about in this time, it's 2004. This is where we started to get the idea of kind of a single page app thing. It wasn't quite single page appy, but this is where it kind of started in this decade. It's also where we started to get some front end libraries coming out. We had ones like Dojo, got a little timeline here. So yeah, Gmail and Dojo in 2004, YUI, jQuery and Sass in 2006, and XJS in 2007. Mostly these front-end libraries were concerned with smoothing off the rough edges when dealing with cross-browser things in JavaScript and CSS. So I mentioned before that back in the early days, it could barely support JS and CSS, and when that support did come, it came in different flavors. IE was the dominant browser then, Firefox was brand new, Chrome didn't come into the scene until a little bit after. but they all supported different portions of the spec in different ways. And so jQuery, as we all know, came out as the dominant player here, the most successful one to smooth those edges off the best, and did quite well. These libraries were also the backbone of the single-page app movement. So if you weren't using these, it would have been very, very hard to try anything that was kind of like a in-browser app type experience. Then we get to the current decade. This is where we've got the concepts of like the newest HTML5, Universal JS, or used to be called isomorphic JS. And this was an explosion of things for front-end. So there were a bunch of build tools that came out in 2010, Require.js, which was absolutely excellent for what it did. It allowed you to modularize your JavaScript code and just load things at build time rather than having to code it all into one gigantic file, and we've all been there. Browserify came soon after and took that concept and ran with it and made it really good. Webpack came soon after that as well. Webpack is now the dominant player. So 6 years later, it took for it to become the dominant player, but it started back in 2012. Grunt is more of a task runner, for those that aren't familiar. And then we've got things like Rollup and Parcel, which are the more modern options. They target mostly just very modern JavaScript. So they do away with all the baggage that something like Browserify or Webpack has, and say, okay, we're only going to focus on modern applications. When they do that, they're able to take advantage of a lot of the awesome features in the new language spec. So it enables things like tree shaking to reduce your bundle sizes and increase page load speeds and those kinds of things, which is great. Then we have a bunch of frameworks released in this decade as well. Angular, 2010. I'm actually surprised it was 2010. For whatever reason, I thought it was earlier than that. I thought it was around 2005 or so, but 2010 it was. Knockout Ember, 2011. Meteor, React 2013. I was actually really lucky. I was in San Francisco at the end of 2013 and got to meet the React team at the time. Had a really good chat with them. I was at an event at Facebook headquarters, and I basically tried to convince them that they were completely wrong and they had no idea what they're talking about. Obviously, I was the wrong one. They had it all right. I just didn't quite get it. And hopefully, after today, I'll be able to impart the things that I've learned to you, and you'll get it as well. The most recent player here is Vue.js. Around when React was released was roughly when isomorphic JS was a thing, where you can run JavaScript server-side and client-side, and it's the exact same code. Didn't quite work out like that. Then we've got the latest trend, which is kind of frameworks of frameworks. So in 2016, both Next.js and Nuxt.js were released in the same month as well. Next.js is a framework on top of React. It allows you to do that isomorphic JavaScript thing without having to worry about all the details. You create a new Next app, and you have server-rendered React, as well as client, all the benefits for client-rendered stuff. And then Nuxt does the same thing for Vue.js. There's also Angular Universal, which does a similar thing for Angular, but I couldn't find out when that was released. Does anyone here know when Angular Universal server-side rendering for Angular was shipped? 2015, maybe? Okay, cool. Yeah. So it's around the same time. So you can see this pattern kind of emerging recent days. So there's still these pain points that need to be solved that just React on its own doesn't solve. People are building on top of that. That's a lot. You fatigued? I am. So JavaScript fatigue, the phrase was kind of coined in 2015. Way too much stuff going on. But it kind of goes back before that. 2014, there was this idea of framework fatigue. I even found this one tweet by Syndrasaurus trying to coin YAFs, yet another framework syndrome, back in 2012. So yeah, I mean, I was fatigued by this point as well. I'd gone through all that churn. I ended up picking one and running with it. Mostly arbitrary choice. It seemed to tick all the boxes, but it was very early days, and the one I picked was React. Now, I'm glad I did. I've stuck with it since around 2014, so around 4 years of doing React, and haven't felt like I've needed to switch away. Every challenge I've come across, React has been able to solve for me. The ecosystem has been evolving and growing around me. I've been able to leverage all that, which has been absolutely excellent. React came with a promise. This is off their website today. They talk about how React is declarative, and those declarative views make your code more predictable and easier to debug. That's a big thing, being able to easily debug your front ends, because notoriously, it's much harder than, say, back-end code. And it's component-based, so you're able to encapsulate certain chunks of functionality into components. They manage their own state, and you can piece them together to make complex UIs. So I think this really, these two concepts are the core of why I think React is so excellent. I think if it was either one of these, it would be good, but it wouldn't be great. With both of them, I think this is what really made it so popular. It took a little while for people to kind of get it, but when they did, I think this is the core reason why. Now it helps to be able to think in React. Reading about it doesn't really help. So let's run through a bit of an exercise. This is taken out of and modified from the React.js docs, reactjs.com. It's just a simple exercise of kind of getting your mind in the mindset of components, React components. So let's start out with a mock that our design team has given us or that we've come up with. And let's assume that we have a JSON API that's returning this data. And now we just need to put it into a UI for us. So first we go through and we look at what are all the parts of this UI. Each one of these colors here, there's an orange border around the outside. There's blue, green, kind of a turquoise color, and then a red color there. Signifies a single chunk of the UI. And you'll notice that it's nested as well. So it's not just rows, it's not just columns, it's a nested UI. When you think about it like this, and say the designer comes back to you a little bit later and says, well, actually, no, we want to swap things around. We want the search bar at the bottom. Then you're able to look at this and say, oh, look, the green and the blue boxes swapped, but nothing else changed. So this is the first kind of step you need to take towards thinking in React. You're thinking about this hierarchy of components that you're able to move around and remix. Kind of just moving the blocks around. So let's look at this in a slightly different way. So here's our two examples again with the search at the top on the left and the search at the bottom on the right. Let's write out what we might call each of these colored components. So the entire thing might be called filterable products. Then we've got the search bar, products, category row, and product row. Then when we rearrange things, we've got the products and the search bar have been swapped around. And it's a little bit tricky to see here. So if you're thinking about things just in a row format, it's kind of hard to tell where things moved. But when you write it out as a hierarchy, then it becomes really obvious. It's the fact that the products and the search bar swapped, but everything nested underneath products didn't move. You didn't have to touch those things. So this is the really key concept. This is the really important thing. If you're not familiar with React, I want you to take this away, is thinking about things in terms of components and their hierarchy in the UI. This is the core thing that I think React does really, really well. There you can see it highlighted there. So components unlock the front end. Who said that? I did, this guy. Now that's important. It's important because it helps me building a business. I am the only person working on my business now, but in the future I hope to grow the engineering team, grow the design team, all those kinds of things. If I'm able to onboard a new engineer and that engineer is able to pick up a single component and edit that component without fear of it interfering with the rest of the code base, then that's a huge win for productivity. If we are able to onboard a designer and they're able to design an individual component that can slot in with the rest of them, then that's a huge win for productivity. I've refactored a lot of websites in my time. I've built a lot of websites from scratch in my time. I've made a lot of mistakes, and I've noticed that in my time using React, I've made a lot fewer mistakes. It's much easier to fall into the pit of success when using React, and that's because of this component architecture. One of the key things for Cete, for my business, is to be able to iterate quickly. And so I have been betting on React that it will enable that now and into the future as well. Even if I end up with a very large code base, it'll be based on components and I should be able to churn quite quick. Now, talking about designers onboarding, we may all be familiar with design systems. So there's two of the most popular design systems are Google's Material Design, that is the way that they build all of their products, and the other one is the iOS, I believe they call it Human Interface Design. In both of these cases, the screenshots you see here are made up of many small components. If you go through their docs, they will talk about things like an avatar component, a list item component, an icon component. And this all goes up together to make a design system. Now, in both of these cases, they mostly talk about it in terms of the design side of things rather than the code side of things. But then they do, behind that layer, they do have the code side of things. Interestingly, for Google Material Design, there's a library called Material UI, which implements this in React, which is really excellent if you don't mind the aesthetic. Some people don't like the material design aesthetic, but personal choice. This is the designer's version of components. They're able to take this design system and remix it into any format that they need by just rearranging the components that they see on the screen. But these don't necessarily correlate to code. So design systems are great, but they're not quite components. They may also, you may be thinking, okay, this is great, this is Google and Apple. These are two of the biggest companies in the world, and they've got hundreds of thousands of people there, thousands of people there, thousands of engineers certainly. They've got all this time to spend working on this. Well, I would challenge that it's only for the big companies. I think it's also applicable for smaller companies such as mine, such as Cete. There's this excellent article by Marius called How Small Teams Benefit from Having a Design System. The general thesis is that once you have it in place, it's an upfront cost, but then over the long term, it allows you to iterate quickly. So again, it takes advantage of that component-based system. And in startup land, being able to iterate quickly is king. But I might be hearing you say, well, okay, design systems are great, but that just enables the designers to change things at their will really quickly and throw the design over the fence, and here I am, the poor sucker that has to code it all up. Fair enough. So there's this concept of code as the source of truth. This is a fairly modern, fairly recent movement. The biggest, the most high-profile example of this is Airbnb, who've been trying to make their code the source of truth, not their designs the source of truth. The way that they do it is they will initially have to design things. That gets turned into code, but the code then is the thing that both designers and developers refer to. So if they need to make any changes, they will load up the code and they will make the changes there, either visually or through the code. And they might export that back to a design tool, but the code is the source of the truth. Now that exporting back to a design tool is important because designers, we don't expect them to be able to code in React. We expect them to use the tools that they know best and work best for their situation. So they built this excellent integration with Sketch called React Sketch App. Now I'm going to try and show you a demo. Hopefully this works, but we'll see. Okay, so this is Sketch. We have some profile cards, a name, and some information about the people. Now what's interesting about these is this is all loaded from what are React components under the hood. So each one of these, the view down the side here corresponds, and the text and the image components, those kinds of things, corresponds to a React component that was loaded in via React Sketch App. Now if I was a designer, I could come in here and I could say, okay, I actually want the profile picture, I don't know, down here somewhere. Whatever, it's horrible design, I'm not a designer, sorry. Alternatively, what you could do is work with the developers, load up the code that powers this. Apologies for the syntax highlighting there. But you can load up the code that powers this and go, okay, here's the avatar component. This is the one that I want to move. I want to move it below the title and the subtitle. So I edit the code, I save that out, I jump back into Sketch, and ideally, after hot reloading, it will have moved it down for me. So in this way, this is actually very, very powerful. There's a lot that's going on behind the scenes. It's recompiling all of the React code, it's outputting it into a Sketch file, reloading that Sketch file. There's a lot going on. On the surface, it doesn't look like too much, but when you get a designer and a front-end developer in the room together and they're able to iterate on a tool like this, it unlocks a huge amount of productivity. it's really important that these kinds of things exist. There's a derivative of React SketchUp called HTML SketchUp, where if your code base is not in React, if you are just outputting HTML, because I know not everyone here will be using React, then you are able to import just chunks of HTML into Sketch in the same way. So then you edit your HTML, it'll re-import into Sketch automatically for you. That's built by Mark Dalglish down in Melbourne as well, so it's supporting our fellow Aussies. So if I jump back to the talk, great, so that's React SketchUp. Now, this instantly caught on. As soon as they launched, Airbnb launched this, hugely popular, and a bunch of people tried it out, loved the idea, kind of came up against some limitations. The fact that it's integrating with Sketch, which is a design tool, it's not meant for importing code. People try to come up with some alternatives. The most recent one is FramerX. They used to have a tool called Framer Studio. The most recent version of FramerX is released within the last month. And I will show you a GIF of using this one with components and code. So here they're editing some properties of a component, like you would in any design tool. But here they're loading up the actual code. And if I am able to pause it towards the end there, you'll be able to see, so they're editing some of the properties, the ripple, the color, those kinds of things. So if I pause it here, we can see that the code here has things like the color embedded into the type system in the code. This is using TypeScript. And you can see that this is imported directly from Material UI, the React component library I mentioned that implements Google's Material Design, straight into a design tool that we just saw the user is able to click around in. FramerX actually takes things one step further and says, okay, this is great, we can import code. Why can't everything be powered by code? And so they did. So every single thing inside a design, inside FramerX, is actually a React component. Interestingly, they do not allow you to export those React components. I think they were burnt by Dreamweaver. I don't know. But they do say what their reasoning is that most oftentimes you export code, but that doesn't actually go to production. You end up rewriting it anyway. Personally, I would like to see that export because I think that export is a much better handover from design to development. I think if designers were able to export a zip file or something like that, or a Git repo of a set of React components based on their designs using FramerX, then the front-end devs will be able to pick that up much, much easier and remix it and rewrite it and get it shipped. So everything is a component. And this is great because this really unlocks a lot of things for us. So now I want to jump into some patterns in React. Ones that you may have seen before. I'm going to try and shoehorn the React patterns into other computer science patterns. You can give me feedback at the end about how well I did. But first up, I want to talk about the small API of a React component. So we'll jump into some code. So far, everything we've talked about is conceptual or design. So let's actually jump into code because this is important. Right? This is why we're here. So this is the most basic example of rendering a React component. At the bottom, we have the entry point. The mount node is just a DOM node. We're using special syntax here called JSX. If you're not familiar with it, it's a way of writing your HTML inside JavaScript. That's the inverse of what Angular allows, which is writing your JavaScript or JavaScript-like inside the HTML. So it's an inverted concept. Then we have our component. In this case, we called it message. And the thing that it returns from the render function is the thing that gets rendered. Pretty straightforward there. In this case, we return a div. And there's a special thing here called this.props. Now, where does that come from? That gets passed in from the top-level component when we're rendering. So it's called a prop, name equals Jane. That appears inside of the component as this.props, dot whatever we call it, so dot name in this case. And that would render out what you would expect, hello Jane. So let's look at an example where there's multiple components. So here we have the message component again at the top, and a hello everyone component in the middle, and at the bottom you can see when we're rendering we pass in multiple people this time rather than one name. So here are our two components. Here we go, we pass in the multiple people. And it renders this hello everyone component. The actual work that it does, this is just JavaScript, plain old JavaScript. It uses a map over an array, and then it returns another component, the message component in this case. And that's kind of building with Lego blocks. We've just pieced a couple of things together. We've got multiple components now, and they just snap together by returning a component from each other. So I want to jump into the pattern. So that's just kind of a brief intro into what React code actually looks like. I want to jump into the patterns. So the single responsibility principle. So this is something that I have tried to follow for most of my coding career. I found it very, very valuable. Right from doing C++ development through to JavaScript development. For those that aren't familiar, it's having the smallest responsibility as possible for one object or one class or one function. Should do one thing and do one thing well is the Unix mantra, which is the single responsibility principle. So let's look at our code again. This seems like it's a bit verbose. Do we really need two components? What about if we just combined it into one component? So here we've got the contents of both of the other components combined into one here. We're doing the map, and we're also rendering the hello name. Excuse me. We can, but then we start to get more complicated code like this, where we have one responsibility here, which is interacting with a sorting function of some kind, and then another responsibility here, which is rendering more than just hello name. Now we're rendering an avatar and maybe a description or other things like the sketch example we saw earlier. So really we've got two responsibilities in, jumped ahead there. We've got two responsibilities in one component. So we really want to split those out. So then we end up with something like this, and this is much nicer. We have one responsibility here wrapped inside a component, and one responsibility here wrapped inside another component. This leads to other great properties of the single responsibility principle of testing. We're able to test these things in isolation. There are excellent testing libraries which are out of the scope for this talk, unfortunately, but this makes those kinds of things much easier. So pattern number 2, dependency injection. Or in React land, this is called child components. So let's start with the same example we just had. And we will have a look at this little extra div that I've added here. Fancy box. So we want to make sure that all the people's messages are wrapped up in a nice little fancy box. This could be a material design with a little hover effect or whatever you feel like. We could do it like so, and I'll zoom in here. So we've got at the top there, we've got a new fancy box component. And down the bottom, we're rendering that and passing the people through. But there's a problem here. We can't reuse this fancy box component because if you look inside it, it still relies on outputting the message component. So if we wanted to have something else that was wrapped in a fancy box component, that's not possible because it's going to render messages, and maybe we want to render avatars or we want to render something else inside this box. So the solution is to use what's called children. So here again at the bottom is our fancy box component, and we can see that we now pass in as a sub-element of the fancy box component the .map function. And then at the top, inside the fancy box component, we have this .props.children. And so we saw before where the name came through as this .props.name. This .props.children is automatically added by React whenever there's a child component inside of the, in this case, fancy box component. So that's highlighting it there. So that's the dependency injection pattern. So we're able to inject something that needs to be executed upon, and that's the children. So the third and final pattern that I will run through today is the interface pattern. Now this one I'm reaching a bit, but I think it kind of maps to interfaces as you know them from class-based languages such as C# and C. C++, sorry, C is not class-based. So let's go back to our example again, and let's jump through to, here we go. So we're inside the fancy box component again, and we're rendering the message component. We're trying to give it a class name of fancy item. What's happened here is something's leaked. Really, fancy item should be contained inside of the fancy box component. The message component shouldn't have to know that it needs a class name called fancy item. So how do we solve this? How do we get it so that fancy box is in control of the class name so that it can dictate, yeah, you need this class name or you need these style props or whatever have you? The solution looks like this. So if we zoom in, we can see that down the bottom now, instead of rendering just the this.props.people.map, now we're rendering a function. It's a little tricky to see, so I'll just show you. So here, so down the bottom you can see that it's actually a function call. This is ES6 syntax in JavaScript if you're not familiar. This is shorthand for a function. And at the top, this gets passed in the same as we saw before as this.props.children, but now because we're passing in a function, we can execute it. And we're executing it and passing it an object with a key called class name. Down the bottom, we extract that class name, and then we apply it to our component. So in this way, at the top, all of the, at the top, all of the logic for what to name the class names is contained within this fancy box component, but it gets passed down through what's called a function, function as a child prop, aka render props, depending on the documentation you read, and then is able to be popped onto the message component. Now, I know this is a little convoluted, so a really simple example is here. So imagine you have a mouse component, and that needs to report back the current mouse X and Y positions. So function as a child, which receives a single argument of mouse, and that mouse is mouse.x and mouse.y, and we render that out. Now these are just 3 of the patterns that I am leveraging in my day-to-day. So just these 3 patterns I've come across in the last week of building UIs with React. And they've helped me immensely with refactoring, I start building a UI and I'm like, okay, this is starting to get complicated. I should pull this out, single responsibility. And then I need to pass a bunch of children in, so dependency injection. And then I think, oh, well, how can I get some more value through, how can I wrap this in a component that can pass the value through? And that's the interface pattern. Like I said, it's a bit of a stretch using render props. But there is a lot more. Ken C. Dodds has an excellent egghead.io course. I highly recommend you go check it out. Advanced React component patterns. There's a ton of lessons there. They're all really short, really easy to digest. 100% think you should go check that out. Also, if you check out the official React.js docs, they cover these and a lot more. They go a lot more in depth with React. Also recommend you check out the Getting Started in React on reactjs.org. It runs you through using all of the concepts of React by building a little mini game in the browser, which is a bit of fun. So I want you to leave here with something practical. Getting started. How do you get started with React and start creating UIs? There's a really strong ecosystem out there. The very first thing that you should probably use is create React app. This is a little GIF. They've run npx create React app at the top there. That then downloads and sets everything else. So you know before when I talked about there's Webpack and Rollup and all these other build tools and that kind of stuff. React still depends on these, but you don't have to care. Use create React app and it will install it all for you and get it all up and running. Then you have one command away at yarn start or npm run start, and it will open a browser and you will have a fully rendered React component good to go. And you can just edit I believe it gives you an app.jsx file, and then you'll see code similar to what we just saw. if running things in the terminal is not your thing, then there's this really great GUI called Gubbi. Go check it out. That's the GitHub link at the bottom there. It basically takes Create React App, slaps an excellent GUI on it, and then also allows you to run other commands. So you can see in this example, there's in the middle of the screen there's build, test, and eject. So if you need to do things a bit more advanced, you can eject out of this system. Also, the UX on this app is just insanely nice. Unfortunately, I don't have it installed, but I wish I did, because there's just some really nice touches with the animations when you click buttons and those kinds of things. It's a really good example of how to do good UX. When using Create React App, that will only give you a component that's renderable inside of the browser. It's not server-side rendering, doesn't have any of that infrastructure that comes with it. There has been talks about adding that, but it's not there yet. Now, one of these frameworks on a framework that we mentioned before is Next.js. Highly recommend you check this out. It is fairly lightweight on top of React. You don't have to learn too much extra beyond knowing just vanilla React to be able to get server rendering. The best way to get started with Next is using Create Next App. So we just saw Create React App. This is Create Next App. And it comes with a bunch of examples. In this example, I've used styled components. They called it with style components here. Check out that URL for a bunch more examples. There's 40 odd of them. So if you have a particular tech stack that you need to use, or particular library that you want included, then one of those examples will surely include it. Get started. This just spins up. It clones everything, spins it up for you, and similar to Create React App, you now have a fully server-side rendered React component that you can just jump in and start editing straight away. So with all of those things in mind, I am betting my business on React. I think that it is an extremely powerful technology. I think the ecosystem is very strong. The folks at Facebook have bet on it themselves. All of Facebook.com is powered by it. There's many thousands of other businesses around the world. Airbnb is another famous one that are betting on this as well. And so these are some of the reasons why. There is a lot more. Ben gave an excellent talk earlier today on the React ecosystem, and he filled an entire hour of things that exist there, and I'm sure he could have gone on for a second hour. Highly recommend you check out the recording of that, NDC Sydney 2018. Check it out, because it's worthwhile watching. And that's me. Thank you very much. Do we have time for questions? I think so. Does anybody have any questions? In the middle there.
Hi, I have a question regarding the motion control. For example, for most companies, for big companies, they have design system, right?
Mm-hmm.
So wondering, for example, for your company, do you have in-house React components can be reused by other teams? It's like framework stuff. For example, you are going to create your own framework for your company. I was wondering how you guys manage the motion control, the ecosystem inside the company.
Mm-hmm.
The reason why I ask, because sometimes we may end up the maintenance overhead, because, for example, there's in the big community outside, they have some very mature framework like Bootstrap, React Bootstrap, all this stuff. Also people are opinionated. Sometimes they use React components in different ways, but they achieve the same result. So what I mean, how you guys deal with this kind of stuff? Is something inside your company?
Yeah, so just to repeat the question, in a larger company, how do you deal with design systems that are built up of React components versus using an external design system that's built up of React components? Is that generally the idea there?
Yeah.
Awesome. So I had a lot of experience with this at Domain while I was the front-end architect there. And what we found was that we were able to leverage a lot of existing components and then wrap them in our own components that fit into our design system, into our component library. Things such as React Select. It takes away all of the complexities of worrying about an accessible select box that has type ed searching and all these advanced features, but allows us to style it and customize it to our particular needs. For example, on domain.com.au, the homepage is a type-ahead search for properties in Australia. Without React Select, it would have taken a lot longer to build that functionality. But we were able to wrap that in our own components in domain and then deploy that as part of our component library. That then came with maintenance overhead. We had to then maintain that component, but the maintenance overhead was much, much lower than the time we would have spent trying to build a select box for the same functionality. For a smaller company such as Cete that I'm running, I would look to leverage more of those components. So something like Material UI, which implements all of Google's material design in React. I would look to leverage something like that. There's also some really cool libraries such as styled systems. So it allows you to do this idea where every component is made up of a series of configurable options. You have a box component that has a width and height configurable options, and you import that from styled system, apply it, and then you can use the box component anywhere and just give it like a W equals and then a number, and that sets the width on the component. You can do that for colors, you can do it for theming. There's a whole bunch of other things that allows you to do there, which then gives you this good halfway point between going all out and designing everything and having a one set component that should be used everywhere and a fully reusable component that you then have to fully style from scratch every time. That gives you kind of a good middle ground. There's a bunch of other options like that out there as well, but styled system is the one that I've used. Any other questions? In the middle?
I just want to know your opinion if you're gonna start a new project, will you use Create React app or any React boilerplate and you customize?
Good question. So if I was starting a brand new project, would I use Create React app or possibly a boilerplate setup? Yeah. So Create React app is kind of a boilerplate setup already, but it only gives you so much. It only gives you the things needed to render that component in the browser. If you were to then use a CSS and JS library like styled components or Aphrodite or anything like that, you have to add that on yourself. So it doesn't go very far. It also doesn't deal with any of the server-side rendering stuff. So it really depends on your use case. If you just need something to render in the browser, then Create React app is great. If you're just playing around, Create React app is great. If you need something a bit more than that, such as server-side rendering, then Next. I would highly, highly recommend using Next and Create Next app. There's also, funnily enough, the avatar that you saw that I played around with in Sketch, that's Max Stoiber, who lives in Vienna. He is the creator of styled components, but he also maintains React boilerplate. And it is a fully featured boilerplate that gets you up and running with essentially a complete website, and you just need to fill in the blanks. So it's very powerful. But some people might say that it is very bloated because it includes a lot there. It's really up to your use case. It's not like other frameworks or libraries where they say, okay, here's the entire thing, now go. React is very much, here is the view layer, now you pick everything else. That has its pros and cons. Decision fatigue, we ran through that. But I would recommend starting with Next and their examples. That's probably the best place to go. Question, Dana?
Just wondering, in terms of Preact, is that, what's your view on Preact?
So what's my view on Preact versus React? So Preact is interesting. They took the concept that React launched with, used a very, very similar API, but cut a bunch of things to make the bundle sizes much, much smaller. And in the early days, they made rendering quicker as well. So there was less of a performance hit of rendering complex UIs. In the early days, if your goal was just performance and just bundle size, then I would have said yes, you could use Preact. These days, there's not much of a use case for Preact. The React team have done an amazing amount of work on performance optimizations, reducing the bundle size. They've got some upcoming work they're calling React Fire, because they want to make it blazingly fast, where they're going to reduce the bundle size even more and speed things up. They recently shipped React Suspense, which does a lot of things like async rendering, which is a very tricky thing to get right, and it looks like they've kind of nailed it, which is good. I know they're using it on Facebook Live right now, and they've seen huge improvements. So I think I would bet on React. they're not going away anytime soon. There's no indication they're going to abandon the project. And I think Preact is a much smaller team as well. There's other ones. Inferno was a similar one to Preact. Similar thing. They reduced the scope of the library, but made it really, really fast and really small. And that's great. And I encourage people to check those things out if that is your goal. But if your goal is general UI, then stick with React. Yeah. At the back. Sorry, can you speak up?
How do you compare React with Angular 6?
React versus Angular 6. I'm going to stay away from that topic. I want to just talk on React's strengths. I don't want to put either framework ahead of the other, because I think they both have their strengths. I get this question kind of once a month at the React Sydney meetup, and I usually give the same response, I'm afraid. There's plenty of articles out there. Feel free to Google for it, but I don't think it's very productive doing so. Down the front.
You used Node and GraphQL and React.
Yes.
What is your view on React with the Microsoft stack?
What is my view on React with the Microsoft stack?
Yeah.
I have not used it beyond, I touched a little bit with it at Domain, where they did use React.net, which allows server-side rendering of React in .NET.
Right.
However, we ended up not going with that route and just spinning up Node servers to do rendering specifically. And I know Eventbrite does a similar thing, Airbnb does a similar thing, where they've decided on the best route being to use Node to render React server-side, but keep your existing language and stack for everything else, for your microservices and all those kinds of things where it makes sense.
I want to hear your opinion about React Native.
React Native. Okay, so I have not used much of React Native. The excellent thing about it, though, is that I know React, and React Native uses the same API. I should be able to pick it up really quick. And for all the experiences that I've heard other people tell me, they are able to, but it comes with its own quirks. It's kind of like, okay, you can learn React, it's great, but you still need to understand how the browser works to get the most out of it. You're probably going to hit pitfalls of like, oops, I was meant to render this, but a promise resolved and it rendered that instead. Same thing can happen to you in React Native. It's very, very powerful. It does have shortcomings. The way that it's structured means that you have to call out to native code across an async bridge, which means doing synchronous rendering is really difficult. However, like I mentioned before, the async rendering that they're bringing to React, they're also bringing to React Native, which then solves that problem. And they're doing a major refactor of the React Native codebase, or they may have just recently completed. I'm not sure exactly the status, but it's very powerful. I would recommend it over, if you're just getting started, I'd recommend it over other universal mobile libraries. It's definitely worthwhile checking out.
And also, another question. So basically, if you're starting off a new project, would you be able to consider to integrate React Native with React as well, altogether?
So the question is, how could you integrate React Native and React for web together? So they don't, fundamentally, they don't work together. The primitives are different. On React Native, you have a text component. In React DOM, which is the browser version, you have a span component. Span does not work in React Native, text component does not work in React DOM. However, there are libraries that smooth over those differences. I think it's called React Elements from Airbnb, and there's a couple of other libraries that do similar things. So you can, if you're conscious of it when you get started, there are ways to smooth over the differences. However, you will find yourself reaching out into native-specific things or browser-specific things at certain points, just because they don't have the same feature sets. They're not the same platform. Even across iOS and Android, they don't have the same feature set, so you will end up dropping into, I think the way they do it in React Native is if it was like a map component, it'd be like map.android.js along those lines, and that's how you target Android for that component. I think we're out of time, but thank you so much, everyone. I really appreciate it.